Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a square minus b square equals to 65, and we solve this problem for all the values of a and b. So here you remember one thing is that our a and b should must be a positive integer. It means that we solve this problem for all positive integer values of a and b. And now we move towards the solution of this problem from first method. So here you see that in the left hand side, this is the very famous algebraic formula. So a square minus b square equals to a minus b times of a plus b, and this is equals to 65. So you see that in the left hand side we have two factors are multiplied by each other, but in the right hand side we have only one factor. So first we need to find any two positive integers whose product becomes 65. So the possibilities are 1 times of 65 is equals to 65, and 5 times of 13 is also equals to 65. So there are two possibilities in which we get the product of two positive integers becomes here 65. And if we make the relation between a minus b and a plus b, we just say that a minus b is always less than a plus b. So here if we make the relation between these two pair numbers, we also say that 1 is less than 65 and 5 is less than 13. So here we make two cases, and we write here the lesser value equals to lesser value and greater value equals to greater value. So here in this side we write our first case, and in this side we write here our second case. So in the first case we compare a minus b and a plus b with 1 and 65. So we write it as a minus b is equals to 1 and a plus b is equals to 65. So in the second case, we compare a minus b and a plus b with 5 and 13, and we write it as a minus b is equals to 5 and a plus b is equals to 13. So we have these are the two cases, and we solve these two cases and we get the values of a and b from these two cases. So now here first we call this is the our equation number 1, and we call that this is the our equation number 2. And now first we solve both of these two equations and we get the values of a and b. And now here we first sum up equation number 1 and equation number 2. So when we add both of these two equations, we obtain here we just get, you see that this is negative b and positive b are cancelled out by each other, and we get here a plus a becomes 2a equals to 1 plus 65 becomes here 66. And now here we divide both of the sides by 2 in order to get the values of a. So this 2 and this 2 are gone, and we obtain a is equals to, here we cancel these terms, 2 3s are 6 and 2 3s are 6. So here we easily get the value of a is equals to 33. And now we use this value of a into the equation number 1, and we get the corresponding value of b. So that equation number 1 is implies that a minus b is equals to 1. So here we put this value of a and we get 33 minus b is equals to 1. And we move 1 to the left hand side and b to the right hand side, and we get 33 minus 1 is equals to b. So we obtain 33 minus 1 becomes 32 is equals to b. So this is the value of b which we get here from first case. So in the first case we get the first order pair of solution is ab equals to 33 and 32. This is the first pair of solution. And now here in the next step we need to find other solution from second case. So in the second case we called that this is our equation number 3 and this is our equation number 4. So here we again sum up equation number 3 and equation number 4, and we obtain, so here when we sum up these two equations we obtain this is negative b and positive b are gone, and we get here a plus a is equals to 2a, and 5 plus 13 becomes here 18. So for the values of a we divide both of the sides by 2, and we get this 2 and this 2 are gone, and we obtain a is equals to, this is 2 9s are 18, and we easily get the value of a is equals to 9. So here we easily get the value of a is equals to 9, and now here we copy down equation number 3 here. So we use this value of a in equation number 3 and we get the corresponding value of b. So we have a minus b is equals to 5, and when we put this value of a here, it will becomes 9 minus b is equals to 5. So here we move minus b to the right hand side and we move plus 5 to the left hand side, and we obtain 9 minus 5 is equals to b. So 9 minus 5 becomes 4 equals to b. So this is the value of b, which we get here from second case. So in the second case, we get the order pair of solution is a b equals to 9 and 4. So these are the two solutions which we get here in this method. And now here in the next steps, we need to verify that is both of these two roots be the solution, or both of these two roots be the extraneous root. So for verification of this, we need to copy down given question statement. Here it is a square minus b square equals to 65. And now here in the left hand side, we substitute both of these two values of a and b in this equation, and we check its behavior. When we put it here, it will becomes 33 square minus 32 square is equals to 65. And you know about that, 33 square becomes 1089 and 32 square becomes 1024 is equals to 65. And you clearly see that 65 is equals to 65. So this means that both of the sides are equal. It means that the value ab is equals to 33 and 32 is satisfied our given question statement. And now in the same pattern, we verify the second values of a and b, and now we put both of these two values here, and it will becomes 9 square minus 4 square is equals to 65, and 9 square becomes 81 minus 4 square becomes 16 is equals to 65. And here we subtract both of these two values and we get 81 minus 16 becomes 65 is equals to 65. This again shows that both of the sides are equal, and if both of the sides are equal, this concludes about that the second value of AB is also satisfied our given question statement. So here finally we have these are the two solutions of the given equation which we get here from this method. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.